From the previous example, we can see that we can tell the local maximum or local minimum is also the absolute maximum or absolute minimum if we have that this is the number line for f prime of x and we just have a point. Then on one side, for example, this is the point C. Then if we have on the left side of C, f prime is positive and then negative, then we know that this C is not only the local max, but it's also absolute max. So we only have 1, 0 of the f prime of x. Or the second case is similar. If we have f prime negative and f prime positive on the left side and the right side of C, then we notice that the point C will be the absolute minimum value of the function. Example number 3. Find the point on the parabola y equal y squared equal 2x that is closest to the point 1, 4. So we want to minimize the distance of any point on the parabola. This parabola is open to the right to the point 1, 4. So we recall that in algebra, we learned the distance formula is between the point A and the point B. So xb minus xa square plus yb minus ya square. For the point A is xaya and the point B is xbyb. Now let's consider any point on the parabola is x, y. Then we have the distance is x minus 1 square plus y minus 4 square. But this point is on the parabola y squared equal 2x. So then we can plug this in. Now let's just make in one variable. So x is 1/2 y squared. Now I will plug in. So I will get 1/2 y squared minus 1 squared plus y minus 4 squared. So what do we want is we want to find that point to be closest to the point 1, 4. That means we want to minimize the distance. But the distance is the square root. So if we square this, it will be the same. So if it's the smallest number, then when you square, it's still the smallest number. Okay, so for example, you have 2, 3, and 5. So if you square them, the square of 2 will be the smallest anyway. Okay, so instead of we want to minimize the d, it's the same thing as we want to find the minimum for the d square, so that we can get rid of the square root. It will make our life much easier. Okay, so they could be the same. And then I will name this is the function f of y. Okay, now let's find the first derivative. Then we will use the chain rule. Now we open parentheses and combine like terms, so we will get y cubed minus 8. Then we only have the 0 for f prime of y is 2. So we only have 1 point. So negative infinity to positive infinity, and we have 2 is here. We test in the point. Anything that's smaller than 2 will give negative, and anything that bigger than 2 will give positive for f prime of y. So we will have going down and going up. So we can go back and apply the first derivative test for the absolute extreme value So we can tell that this point is not only the local minimum, but it's also the absolute minimum. Because it's only is himself, only one. If we have a multiple of them, then the point may be absolute mean or maybe a local mean. But if it's only one point, then we know that it have to be absolute mean. Okay, absolute mean at y equal to 2. Then to find the x, we will plug in into here. Okay, so x equal 1/2 times 2 square, and that's give us 2. Okay, so the closest point on the parabola have to be 2, 2. Now, if we take a look at the graph, and we will see that it makes sense for us. So we have y here and x here. For the parabola, if you plug in x equal to 1, then so this is y squared equal to x, right? So if x equal to 1, then y squared equal to 2. So y equal plus minus square root of 2, so which is 1.4. Okay, so we have 1 on the x and 1.4 on the y. If we plug in 2 on the x, then we will have 2 on the y. Okay, so we will get this point. Plus and minus 2. So we have this parabola something like this. Parabola something like this. Okay, so the point that we said that this point is our answer is 2, 2. It will be closest to the point 1, 4. So let's plug in the point 1, 4. So this is the point 1, 4. Okay, so we say that the distance from 1, 4 to 2, 2 will be the closest for 2, 2 is on the parabola.